আসসালামু আলাইকুম বিসমিল্লাহির রহমানির রহিম আমরা we are just discussing Palo Alto network basic certification PCNSA. We'll follow PCNSA study guide who is provided by Palo Alto. We are just discussing section 2.6 identify and configure firewall interfaces. We're discussing in last class we have discussed tab interface, virtual wall, layer 2 interface. Today we will discuss layer 3 interface, layer 3 sub interface, and aggregate interface. Okay. So first go to layer 3 interface section. Virtual wall. Layer 2 is the layer 3 interface. Okay. In layer 3 interface where this interface support IPv4 and IPv6 addressing. So if an interface type is layer 3, we can also sub interface this physical interface. You can compare with Cisco, that's called interVLAN routing. For interVLAN routing, one physical interface will be divided into multiple sub interfaces. In Palo Alto also, same scenario. If you want to divide one physical interface into multiple sub interfaces, we can do. You can do. Okay. So see the our lab topology. This is the firewall, and this is a single line interface. Ethernet 1 by 2 single line interface, but in LAN side there is two VLAN 101 and another VLAN is VLAN 102. VLAN 101 subnet is 101.0/24 and VLAN 102 102.0/24. There is two network in a LAN side, in LAN side. So these two interface need two gateway IP. So if you connect two interface like this, one in network gateway will be configured here, another network gateway will be configured here. You can do this, but if you consider there is a hundred of or thousand VLAN is implemented in LAN side, hundred or thousand VLAN implemented in LAN side. So one VLAN need one subnet or one network. Every network need one gateway IP. So Palo Alto have so many interfaces. In Palo Alto, you need so many interfaces if you consider this type of deployment. So if I sub interface in or divide physical interfaces into multiple sub interfaces, per sub interface we can assign per network or its network gateway. So this is called in Palo Alto, this is called the sub interface, but in another vendor like Cisco, this is called the inter-VLAN routing. So inter-VLAN routing means one VLAN network is can communicate with the other VLAN network. This is called the inter-VLAN routing. So we will configure today how to deploy sub interfaces or inter-VLAN routing in Palo Alto. So this is our today's first task. So go to lab now. So first access Palo Alto in graphical window. This is your dashboard. First, go to the network section. In network section, left top section is or top menu is interface. Select the interface menu. You will get multiple interfaces. Select Ethernet 1 by 2. Ethernet 1 by 2 is the LAN side interface. So select the LAN side interface Ethernet 1 by 2. See here, add sub interface. This option is disabled. This option is disabled because the interface type is tab. If you select the interface type is layer 3, then this sub interface section will be enabled. So change this one first. Change the interface type. Interface type is layer 3.
So where it's mandatory to be a interface layer 3 interface to enable sub interface.
Yes, yes, mandatory. See, now this is enabled. Now this is enabled. If you select the any other interfaces like layer 2, interfaces, see here, you get layer 2 interfaces. Also, you get, if I just send commit, just I want to check this option is available when I said the interface type is layer 2. Configuration succeed. Select layer 2. Yes, sub interface is enabled. You can set anything here. You can set something here related to layer 2. So I want to test layer 3. I no need layer 2 interface here. I need layer 3 interface here. That's why I change. That means tab interface will not give you the sub interface option, the interface type tab, and other interface type like ASA, ASA will not give you the option. And another ASA means high availability. Tab ASA virtual wire will also give you to
So
give you
only
an
tap
option.
only
Only
the
tab
tap
and
interface and
ASA.
the HA is
Yes,
working.
only tab and ASA will restrict you to configure the sub interfaces. So in our lab, we need layer 3 interface. So I select layer 3 interface, then OK. And see here, sub interface now enable. I can configure sub interfaces. OK. See here two VLANs, VLAN 101 and 102, and the two different network. So add here sub interfaces. See here, this is the physical interface. This is the main interface, Ethernet 1 by 2. And this is the sub interface ID. And sub interface ID will be start from 1, not 0. Start from 1 to 9,999. So I set here as per VLAN, I set here 101. You can set any comments here, or this is the description basically. If you compare with Cisco Juniper, and this is the VLAN number. Tag is equal to the VLAN number which you configure in your switch. So our VLAN number is 101. And select, just okay. See here, Ethernet 1 by 2, one sub interface added. Ethernet 1 by 2 101. That is also a layer 3 interface. That is also a layer 3 interface. You can add you can add next sub interface. Sub interface is 102 and billion tag will be 102 and just okay. See here, two sub interface is added. So how many sub interface you can add? The sub interface ID available is 1 to 9999, but here is VLAN will be maximum 1 to 4094. So in that case you can say maximum sub interface possible in physical interface is equal to 4094. Okay, so select one sub interface and select the virtual router. Our virtual router is default, where we not create any virtual router. So all interface will be in default router. Okay, that's why I select the virtual router is equal to default. Security zone. This is LAN site. Okay, so this is LAN site. So security zone will be LAN. Security zone will be LAN. So we need to set the IP address now. So I set here IP address statically. So add the IP address. I can set here IP address here, which I already show in previous lab. So I use here in different options addresses. You can set the name here like VLAN 101, and you can set your description and you set here the IP address with mask. So in our lab, the VLAN 101 subnet will be 172.168.101.1/24. Okay, so then just click the OK button. Then
So where it's not mandatory to be the interface number and tag number should be same.
no
Have to be
mandatory.
same.
You can set here sub interface number 110 and tag number 101. No issue. But
Okay.
you have to maintain this tag number will be the VLAN ID. This VLAN ID must be created in your switch and configure
Yes, yes.
accordingly. Okay,
Okay.
but sub interface ID you
Yes.
can set any number, no issue.
Okay.
So
Okay.
it's just like a comment.
Hmm?
It's just like a comment. It means tag field when you use it's like a comment.
And not just a comment, but you have to maintain a number. This is not a comment. You have to maintain a number, any number. You can choose any number,
It's
but
the actual
you have
it's
to
the
put.
villain number.
Or normally we practice villain number and sub interface number is same. We maintain, but there is no obligation. You have to maintain sub interface number and villain number will be the same. Clear? Okay, so click 102 VLAN and set your virtual router is default and security zone is LAN. Okay, and set the IP address. IP address is, you can add the IP address here, or you can add like this, VLAN 102, and IP number will be 172.16.102.1/24. This is this subnet gateway IP. That's okay. Then okay. So see here, IP address not select here. IPv4 102 already select. Yes, 102. See here tag 101 and 102. This is not in virtual wire, and security zone is LAN. Security zone is LAN. Okay. So now sub interface create done. Then I commit. In Cisco router, your configuration will be, this interface will be the trunk, and VLAN 101 and 102 VLAN will be allowed. This trunk port and this interface and this all four interface will be the access port. Access port. This interface will be access VLAN 101, and this two interface will be access VLAN 101, and this two interface will be access VLAN 102. 102. Okay, this is the switch configuration. So I just showing you what is the configuration of switch. Show running config. I just create here two VLAN. First task, just create two VLAN, VLAN 101 and VLAN 102. Okay, then go to the interfaces. Interface is J0 by 0. J0 by 0. This is the trunk port. Switch port trunk encapsulation dot one cube switch port mode trunk. This means all VLAN allowed on this port. Okay, get 0 by 1 and 0 by 2. 0 by 1 access VLAN 101, 0 by 2 access VLAN 101, and Z1 by 0. Z1 by 0 access VLAN 102, 1 by 1 access VLAN 102. That's done. Switch configuration. Okay, so this is your PC, PC1. PC1 need IP address. So show IP interface brief. You see here 101. Show IP route and set the default gateway to this subnet gateway IP, which is configured in Palo Alto sub interfaces. Okay, so check the others with other PC configuration. In PC2, this PC also will be in VLAN 101 and the IP is 101.102. PC3 will be, please mute yourself. PC3 will be VLAN 102. PC4 also will be in VLAN 102 and subnet will be 102. Subnet will be 102. And gateway IP, just checking here. This PC gateway IP will be 101. PC3 gateway IP will be 102. And PC4 gateway IP will be 102. It's the very simple configuration. Okay. I configure Palo Alto sub interface. I configure the gateway in Palo Alto sub interfaces. So I want to check the gateway IP from PC1. Just send the ping, but not getting ping. Anyone say what is the reason to not getting the
We
ping?
need policy in the Palo Alto firewall.
Yes, we need policy, ICMP policy, ICMP policy. That means we need, that means you need interface management option. You need interface management. If you want ICMP reachable, then permitted services, which you want, I just select here default. Permitted service will be being SSIs, HTTPS, response phases. So if I select this interface management in sub interfaces, just attaching this one, I will get ping. In advanced section, management profile will be the interface management. This interface management allow the ICMP request. So submit this one, advanced, then select the interface management. Okay, then commit the configuration. Okay. PC2 IP is 102. If you send packet to 102, that will work, right? That will work. If you send request to different VLAN IP, like VLAN 102 from 101, that will not work. That will not work. Eh? This work? That means it's already committed. That means it's a yes, already committed. I allow this one. Okay. So here we can reach one VLAN to another VLAN through the Palo Alto sub interfaces. Through
Yeah, I
the,
have a question.
yeah, yeah.
Well, let's say we didn't add management, interface management profile to the sub
Mm-hmm.
interface.
Mm-hmm.
So can I ping 102.102 from 101 PC3? Can we ping
Mm-hmm.
PC4 from PC3?
Yes.
It should be
No need,
possible.
no need gateway. No need gateway.
Yes.
If you send ping PC3 to PC4, no need gateway. It will work automatically. Okay.
And the
If
request
you,
will
uh-huh,
not reach to Palo Alto, just bypass through the
mm,
switch
right.
to PC4.
Yes. This traffic will be originate from source. This is the source, and this is the gateway. This is the path. If you send PC3 to PC4, if you send PC1 to PC4, that will go to gateway, then back to the PC. Clear?
Here.
Okay. So our sub interface configuration done, and one VLAN network can communicate with other VLAN network. One VLAN network now can communicate with other VLAN network. Okay, that's good. Now, second task is you have to ensure this VLAN network will go to the internet. That means this subnet should be reached this server. should be reach this server. So we need to configure Palo Alto, need security policy, number one. Number two, need net. Number three, need route. 3 tasks. We have to complete 3 tasks to reach from VLAN network to the server. So we complete this task now. So Ethernet 1 by 1. This is the WAN interface of Palo Alto, Ethernet 1 by 1. So this interface type should be in layer 3. Should be in layer 3. Comments is 1. Virtual router is default. Security zone is 1. And your IPv4 IP, IDR IP address, ISP 1 and IP is 209.165.1.2/30. Okay, then okay, also I set here the interface management to checking the ICMP. Interface management. Okay, so our one interface configuration done. We already configured the zone. Zone configuration already. I show you last or previous class. So now we need policy. Oh, in network section, we need static route. So go to the virtual router. We have only one virtual router. Virtual router is default. And go to the static route section. Then add the static route, default route, and default route is 0.0.0.0/0. IP address is 209.165.1.1. You can select here interface. Interface is Ethernet 1 by 1. No, this is not the mandatory option. Mandatory option is you have to set the next hop IP. You can also enable this option, path monitoring. This route, this firewall monitor this gateway. If this gateway is unreachable, this route will be withdraw from the route table. Okay, if I select this one, path monitoring, you can compare this with IPSLA, or you can compare with MikroTik check gateway ping. Okay, if ping is unreachable, this route will be invalid, or this route will be withdrawn from the route table automatically. Okay, this is you can consider this is the best option for static routing to take automatic decision. Okay, select one. So check this one, static route done. Then go to the policy section. In policy section, see here, you configure two sub interfaces. You configure here two sub interfaces. One is VLAN 101, another is VLAN 102. After configuring the two sub interfaces, one VLAN or one subnet is communicating with the another subnet. This is called the intrazone. This is happened because of this policy, intrazone default. Palo Alto intrazone, Palo Alto intrazone traffic by default allowed. By default allowed.
So this policies has been created in
Default.
automatically.
Yes. This is the default policy. I'm not creating this policy. Palo Alto automatically create this policy. Okay. So that's why intra-zone communication allowed. Two VLAN in same zone. That's why from for the policy of intra-zone, this packet will be permitted. This packet is permitted. Okay. So now we need different policy that is called the inter-zone. This is the LAN zone and this is the WAN zone. LAN zone to WAN zone. For inter-zone, you have to set the policy. You have to set the policy. Okay. So security section. Add here. You have to set the name. You can set name like LAN to WAN security. And role type is universal. You can also set here intra-zone, inter-zone, but I'm not interested to specific now. I will discuss later in policy section. I set here universal default. The source zone is LAN, source zone is LAN, and source address is any source address permitted, and the destination section, the destination zone is one, and any destination is permitted, not specific. All application, any application is permitted. Service, application default service is permitted, and action is allow. So send the OK and complete the net section. Add. I do here PAT, port address translation, LAN to one net, and net type is IPv4. Original packet, that means source zone is LAN, destination zone is one, destination interface any, service any, and translated packet you can set here. First option is the PAT. Okay. Dynamic IP and port. Translated address you can set, or you can set here interface. So I set here interface one, interface Ethernet 1 by 1, and the interface IP is ISP1-1. Then okay. See here, and this is the name, not a IP address. This is the name ISP11. This name is added here. Go to the object and see the addresses. You can set here one single IP or subnet in address section. You can set any address here. Okay. So I configured 3 section, complete the default route. Number 2, complete inter-zone policy, LAN to WAN, and complete the net section. Then send the commit. Now we should get ping from LAN PC to the server. So wait for a second. Configuration committed successfully. Close. Then check the connectivity. So this is the server. Enable. Show IP interface brief. The server IP is 1.1 and PC1. Enable ping 1.1. Yes, getting ping. You can also send the trace route. Is it clear?
Yes,
InterVLAN or
bro, it
sub
is clear.
interfaces? Clear. Okay. So sub interface section has finished. Interface management profile. See here how to configure interface management profile. There is one sample example I already show in our lab. The layer 3 interfaces. This is the virtual router section. See here, interface is layer 3, and you can set here any virtual router, or you can set the default router, and you can set here the security zone. Layer 3 sub interface. For layer 3 sub interface, this is the your virtual router, and layer 3 just here different zone, zone 1, zone 2, zone 3, zone 4. You can configure any sub interface in zone. Not need to fix a single physical interface in a zone. You can assign sub interface in a zone. Okay. So see here, when you select the interface, and interface type should be in layer 3, sub interface in enable mode, select the add sub interface, you will get this option. And set the interface sub interface ID and VLAN tag, and set the virtual router and your security zone, and set the IPv4 and IPv6 addresses. In advanced section, you have to set the interface management profile to getting ICMP request or other request which you set in interface management profile. So this is the sub interface section. And now we will discuss the aggregate interface. Aggregate interface is called the LSCP, link aggregation. You can configure LSCP in your Palo Alto device. When we do this thing, when just consider your LAN traffic is now capacity is 1G. So your LAN traffic now increase, and you need more than 1G. So you need to add the just consider you need your requirement is 1200 Mbps. Just consider. So you need to upgrade this link. You need to upgrade this link. You can change your firewall. You can change your firewall which support 10G interfaces. You can change your switch which can support the 10G interfaces. That can single interface will can do this or will can handle this traffic. But if you want to do with this firewall and switch, you need to add the more interfaces. Just consider two interfaces added. So if you configure the aggregate interface or LSCP in two interfaces, this two interface capacity will be 2000 Mbps or 2 Gbps. So your capacity is 2 Gbps, your requirement is 1 or 1.2 Gbps. So your capacity is upgraded, your requirement will be fulfilled, no issue. So you need to aggregate the interface. So if you want to aggregate multiple physical interface in a single interfaces, you can do LSCP. And LSCP other rules which we maintain in different vendor like Cisco, Juniper. This device also maintain the same rule. Rule is to interface or you can add maximum 8 interfaces. You can add maximum 8 interfaces, and interface speed, interface type, interface duplex will be the same. Otherwise, it cannot aggregate. It cannot aggregate. Okay. So consider here you have 2 gigabit Ethernet interface, Ethernet 1/2 and Ethernet 1/3. You just first you have to create the aggregate group. But in our see here, if I select the Ethernet, here I get multiple option. One is add subinterface, another is add aggregate group. But in our lab, when I select the interface, aggregate group is not available here. See here, aggregate group is not available here. But in physical hardware, you will get this one, aggregate interface. Okay. So first you create the aggregate interface. This interface naming will be AE, aggregate Ethernet. This is the default naming convention. You set the number. This can be aggregate 1, this can be aggregate 2. And this interface type should be in layer 2 or layer 3. And enable LSCP. You just configure here LSCP between Palo Alto and Cisco switch. So if I configure in Palo Alto side LSCP in active mode, you can configure switch 1 interface is in active mode or passive mode. But you cannot configure Palo Alto LSCP in passive mode and Cisco side LSCP in passive mode. Both side passive mode will not work, but active and active passive will be work. You have to consider this one. This is the rule. Okay.
So if I
Hmm.
configure a passive mode in Palo Alto and active mode in Cisco switch, it will
No
work.
issue. No issue. It will work. No
Okay.
issue. It will work. Only passive will not work. Other combination will work. Okay. Just create the aggregate interface and the types at the layer 3. Enable LSCP. You can mode set here passive or active. If you set here passive, other device should be in active mode. Okay. So your aggregate
I have a
interface.
question. Interface name AE, this is the mandatory,
This is the
or we can change.
default. No. You cannot change AE. Interface name. Palo Alto select the interface name AE. This is
It's
not the
like
user
a
defined.
Juniper device.
Right.
Another
Okay.
question, we make aggregation in Palo Alto device maximum 8.
Maximum 8. Maximum 8.
Okay.
See here. Maximum ports. How many? 8.
8. Okay.
See here. Maximum port 8. Okay. So after creating
right now I've checked in our office Palo Alto device, but I've not find out any aggregate Ethernet interface.
I also not get any aggregate interface section in the interface section.
That means
I
this
don't know.
device doesn't support
Does
LSCP,
not
maybe.
Actually, our
maybe
office
does not
device is
support.
virtual VM
Hmm.
series.
Hmm.
There's no.
Maybe this one this model is not support, but other model will be support. Maybe some restriction. Okay.
Okay, sir. Yes, sir.
I have not get aggregate interface section here. Okay.
It's have any feature need to our enable for aggregate
No,
interface
no,
create?
no need any feature. No need. I think no need, but we can check. Okay. Aggregate, the interface type is aggregate. Okay. After creating the aggregate interface, you can add the physical interface. Okay. You can add the physical interface in aggregate interface. After creating the aggregate interface, new interface type will be coming aggregate Ethernet. In aggregate Ethernet, you will just add the physical interface. That's the example. So we have just finished in interface section. So any question in interface section? Any question? Aggregate sub interface.
No, right, clear.
Clear. The number of aggregate interface that this name is AE interface group that the PA3200 series, Palo Alto 5200 series, and most Palo Alto 7000 series firewall support is 16. Clear? So this depends on model. This depends on model how many ports support. Okay. All other physical firewall appliance support 8. Other appliance support 8, but these three series support 16, up to 16. The exception is the PA7000 series firewall. This one SMBB, which is 32. Only 7000 series support this model support 32 aggregate interface groups, which is 32 aggregate interface groups, not port. Only the first 60-day interface groups on the other supported firewall models. VM series will do not support. VM series firewall do not support aggregate interface groups. This is the reason.
Yes, sir. Got it.
This is the reason. VM series not support the aggregate interface.
So where
But in
aggregate interface means a group of multiple interface. Okay.
yes,
So
group of multiple
7000
interface.
series support 32 aggregate interface. That means 32
Hmm.
aggregate group
32
or
aggregate group, not the 32 port.
yes, got
Uh,
it.
but
So I can
uh,
put multiple interface in a single aggregate interface group
up to 8 interface,
up to
eight,
8 years
8 interface, except this 3 series. These 3 series you can add 16.
in a single aggregate interface.
Yes,
Okay, got it.
all other physical firewall appliances support 8. So in VM series will not get this one. Okay. So now I will go the next section. Next section will be this one. And this section is identify steps to create, configure virtual router. How to create and configure virtual router. So I yet not configure any virtual router. Only default virtual router already created. I use the default virtual router, but I yet not create any virtual router. If you want to create the virtual router, so when we need this one, just consider if this is your firewall, just consider this the DMG zone. So you want there is a data center here. There is a data center here. So you want separate this data center network, completely separate this data center network. This data center network will not communicate with your LAN zone or with your WAN zone. If this requirement is coming somehow, then you can configure different virtual router and assign the data center interfaces to the different virtual router. And if you attach uh, any interface in those virtual router, those interface network will communicate with each other. But in default, just consider here two routing table, one routing table in respect to default router and another routing table in respect to new virtual router. These two virtual router will not interact with each other automatically. So if you segregate the network, you can consider is two organization need the Palo Alto support, but two organization buy only single router. So one organization is for default router, another organization is for virtual router. You can consider this one. Palo Alto device serve the two organization at a time. So if you consider this like of a requirement, then you can create the virtual router. Okay, so now we configure the virtual router and assign the interfaces and checking the connectivity. Okay, so see here.
So where if we create two virtual router, that means it will work separately.
Right, work separately.
So what I know there is something called VCs in Palo Alto. What's the use case of VCs and what's the difference between VCs and different virtual router, multiple virtual
BP
VCs, virtual system
VCs
or something like that.
virtual system. Yes. See here, you will get the answer. No issue. See here. So this is the physical boxes. Okay, this is the physical boxes and one virtual router. They have own routing information base. They have own forwarding information base. Another virtual router and connected another um, sub interfaces or separate interfaces, and there is also individual routing table and forwarding table. If you want inter-via routing, that means one via route table will interact with other via route table. You can do this. That means one virtual system can communicate with the other virtual system. If you consider inter-via routing. Got your answer?
So we have to configure the interview routing through VCs.
Right. Of course. Okay. Then
And it will be clear, more clear when we
after
go
lab.
practical. Yes.
Yes. Okay. So legacy virtual router general configuration setting. So if you just create the virtual router, so how to create this one? This is very simple. go to the virtual router section and add the one. Set the name here. You can set here VR1, virtual router 1. No interface is added here. And this is the default administrative distance for Palo Alto device. Palo Alto device static routing AD is 10, OSPF internal 30, external 110, and IBGP 200 like Cisco, ABGP 20, and RIP 120. Okay, so set the name, nothing need to change. Your virtual router created, but there is no interface here. There is no interface one. Just create the virtual router. Just create the virtual router. If you want to attach interfaces in new virtual router, you can do from here. Just add the interfaces. Add the interfaces here. This is the one option. And another option is go to the interfaces and select the interfaces and virtual router section. You will get the new created virtual router. You can set here one. So member cannot be deleted because of reference from network virtual router default routing table. This. That means I use this interface for static routing in default router. So we have to change this one first. So go to this one. So default router, then static route. I have to delete this one. Delete. This is static route. Delete it. Then go to interface section. Then Ethernet 1x1. Then set the VR1. Other setting will be the same. This virtual router is VR1. So go to this interface. Default router will be changed to VR1. And this one, this is also in VR1. So our lab 3 interface, 3 active interface, all are in VR1. Okay, so go to the virtual router section. See here, default router is empty. No interfaces is here. All interface is coming here. And go to the VR1 and go to the static route section. Add the static route. Static route is default route, same as earlier. No difference. The difference is just another name, but concept is same.
So we have
Good.
selected
Zero.
default route in the interface
Mm-hmm.
configuration. And
Yes.
as we
Mm-hmm.
moved all the interface from the default route, now the
Mm-hmm.
ping will not work till we didn't
Mm-hmm. Mm-hmm.
select this new route to this
Mm-hmm.
interfaces.
Right. You can set here interfaces, Ethernet. So path monitoring, you can set this one, then add this one. So your static route done using the new virtual router VR1. Wait for some time. That means you will get a flavor. You will get a flavor. That means network virtualization. Network virtualization. This means one physical box will work as a multiple box. This concept is called the virtual router. Okay. Okay. Then commit the command and checking the configuration is okay or not. Configuration succeed. That means configuration is okay. So see here, click this one, route table. That means RIB. This is the forwarding table, and this is the static route monitoring. So see here, no entry is here. Default route. That means default virtual router. There is no entry. There is no entry. So if you select this one, see here, all route table is here because all interface is in the new virtual router. If you just configure another interface for checking, just go to the interface section and create one loopback interface just for testing. And this loopback interface ID is one, loopback one, and this is in default router, and zone will be the LAN zone, and IPv4 at the loopback is the loopback IP LWP loop BA CA loopback 1, and consider here IP is 10.1.1.1/32. I think wrong. Yes, double dot 1.1.32. So check this one, this one, commit. Oh. Close. Your loopback interface is here. And now go to the virtual router section and click this one. Got here is a route table based on, here is a route table based on a default router. Based on default router, you will get a route table here. You will get a forwarding table here and static route monitoring and other routing protocol based on default router. If you go to the virtual router section, you will get same. All routing protocol and routing table and forwarding table will be here. Okay, that means the virtualization, network virtualization. You will get single physical box, and from single physical box you will get multiple route table or multiple logical router, you can say. See here, a static route monitoring. Static route monitoring, this status is up. This status is up, and because of up, you will get the route in route table and the forwarding table. If this Palo Alto box will not reach the gateway, then this status will be down. If this status will be down, this route table will automatically withdraw from the route table. So test this one. So just shut down the ISP interfaces for checking this static route monitoring is working or not. Interface G0 by 0, shut it down. So wait for some time, static route monitoring. Mhm. Static routes. Failure condition any. Preemptive hold time. 2
Time
minutes.
2 minutes.
Long time. Long time. So we have to wait 2 minutes. Or we can set it 1. We can set it 1 and commit. So go to this section, static monitoring. So wait for 1 minute. Okay, I pause. If I monitoring is static route, we have to enable the path monitoring, and after selecting the path monitoring, you have to add the destination IP. So you can set here ISP1 is the source IP and destination IP. You have to write here 209, or you can set here 1.1.1. This is the destination IP. If this destination IP will unreachable from this source IP, and ping interval is 3 and ping count is 5. So this name is ISP1 IPSLA. IPSLA. ISP1 IPSLA1. Then click this one. So submit this one. Comment this one. Now it should be work. Close. See here, default route, withdraw from route table and the forwarding table, because your route is down. Your gateway is down. Clear? Your gateway is down. This is called the IPSLA. Through the static routing, you can monitor this one. So if the ISP interface is up, no shutdown, wait for some time. This default route will be back. See here, monitoring window. Start failed. Interval 3, count 5. This setting is coming from here. This setting is coming from here. This configuration. Okay. This is coming from here. So wait a minute and see static route will be come up. Hold 19 seconds. Getting up, but not ready to pass the traffic. So up, hold 90 seconds. So after 90 seconds, this default route will be in route table automatically. Refresh up, then route table, refresh, default route is coming. Then refresh, default route is coming. Okay. So
So
this
when
is
the monitor finds that this route is this IP is disabled, then it will be automatically removed from the routing table.
right, exactly. This is called the IPSLA. If you compare this with another vendor like Cisco or Juniper, okay. Okay, so static route configuration setting section. You can change the administrative distance if you want, and set the path monitoring. Available to configure path monitoring, you have to configure IPSLA here, and you have to enable the path monitoring. And this section, set the name, and you have to set the source IP, and you have to set the destination IP. If destination IP is unreachable, you will get the route unreachable from the route table. See here down, and this route table will withdraw from the route table. You can check from CLI, show routing field, show routing. This is the CLI command, and this is the route table of CLI. You can also take it from graphical window. You can also take it from graphical window. Same thing. Okay. This is a BGP route engine configuration. If you see, BGP is not available here. BGP option is not available here. In that case, you have to enable the advanced routing. Enable the advanced routing. In our boxes, BGP already activated. BGP already activated, and see here in device channel section, setup, see the device, and close this one. Device section, device management section, device advanced routing at device setup management. Device, this is the sub menu. Device, and then go to the setup section. In setup section, you will get here advanced routing options. You will get here advanced routing. If BGP section not showing in your firewall, in that case, you will get this one. So in our VM boxes, BGP already enabled. That's why this section is not showing here. Okay, so no need to add anything. Already BGP activated, so no need. So so this is the end of this section. And this section is regarding virtual router and how to attach interfaces in virtual router, how to check static routing with the IPSLA, and check our lab LAN segment to server. LAN PC can communicate with the server through the virtual router. I already checking this one or yet not? PC1, then send the ping, enable. It is working or not? 1.1.1.1. Yes, it's working. So that's all for today. If you have any question, ask me.
So how can we export the lab with the configuration of the smart outer units? Yes.
Okay, with configuration, right? With configuration, okay, I'll show it one. I have to shut down this lab first. Okay, I just stop the recording now.